Hello everybody. So in my last video you have already seen that how to convert a number to Roman equivalent, and also how to generate Hailstone number. So these two things you have seen, but that was the iterative version of the program. So today what we will do, we will see the iterative version of the same program. So let us straightly get into the code and write the functions first. So for writing the function, we will be defining a function here. Say the name of the function is RR. RR represents the recursive version of Roman recursive, say. So we'll be taking two different arguments, n and st is equal to a blank string I'm passing here, and then inside it, in our last program, if you remember, then we have used two different lists. The same list we'll be using here. So this was the list that we have used in our last program. The same list we'll be using. So we'll go for a quick revision that what is there in the list. So the first list, you can see that the name of the list is R, and it is having the values like 1900, 500, 400 up to 1. Total 13 values are there. It means it is starting from 0 and extended up to 12. And similarly, there is one more list R1, and you can see that M is the first value, that is in the 0th location, and I is in the 12th location. Now, why we have stored all this value? These are nothing but the Roman equivalent of the number, that is 1000 is represented using M, and which is why I have used here M. 900 is represented by CM. Why CM in this case? Because the value of M is 1000 and anything written on the left is always subtracted, and this is the reason why 900 is written as CM. 500, the meaning of 500 is D, 400 means CD, and in this way actually the things are done. Now what we will do, we will write a conditional statement here. The condition is whether the value of n is greater than 0 or not. So we can represent it in this way also, that if n, and from here we will run a for loop, that is for I in range, we can write here 0 to length of r. It means it is starting from 0 and it is extended up to 12. So let me finish the code first, and then I will explain that how this particular program is working. So in the next line I am checking a condition, as you can see, that if n is greater than r of ith position element, if this happens, then we will concatenate the string, that is st is equal to st plus, you can write here r1 of I, and then one more thing you can write, that is n is equal to n plus, not n plus, rather it will be n minus r of ith position element. And as soon as we reach this particular position, we can break the loop so as to minimize the number of iterations here. Now I'm coming out of it and getting out of the for loop even, and in this particular part I will be writing a statement here. St is equal to, the name of the function is RR, and this is taking two different arguments. The first one is S and the second one is ST. So this is the function call, and last of all we will be writing the return statement, and we will be returning ST from here. So this is our program. Now we will write the main program and see that whether the codes written here is correct or not. So first of all, I am declaring one variable, as the function is returning a value. So the return type will be stored in a variable named as S. The function call is made, RR is the function call, and let us say that we want to convert one number into Roman equivalent, and that is 504. So the output what we are expecting on the screen is 500 is represented by D and 4 is represented by IV. So the output will be DIV. So we'll be displaying it on the screen. So we'll print S directly on screen and we'll find out the output here. So for this I'm saving the program. So this is the program here, and now we will run the program. We'll find out whether any error is there or not. So we'll go for the first run. So here we go, and you can see that the output that is generated on the screen, I have highlighted this part, and this is DIV. It means 504. The output is okay. So what is happening actually when we are passing 504 as function argument, then the value 504 is copied in n, that is the value of n is equal to 504. st is a blank string, you can see here. This is the default argument that is given. R1 array is taken and its values are 1000, 900, 500, 400, 100 in this way, and R1 is representing the Roman equivalent of whatever is written in list R. Now we are testing a condition here whether the value of n, that is 504, is greater than 0 or not. We have taken 504 from here. So 504 is greater than 0 or not. So it is true. So it is getting into this for loop, and in the for loop it is testing a condition whether I in range 0 to length of R. It means it is traversing through this particular list. It is visiting each and every compartment, and when it enters the loop, it is testing the condition whether n, means 504, is greater than R of ith position or not. So what is I? I is initially 0, so it is checking 504 is greater than 1000 or not. So it is not greater than 1000. Then the value of I is incremented. The value of I becomes 1, and it tests a condition that whether 504 is greater than 900 or not. So it is not. Then again I is incremented. The value of I is now 2, and now it checks whether value of n, that is 504, is greater than R of ith position, that is the value of I by this time is 2, and the condition is satisfied here. When the condition is satisfied, then here we have written a statement. You can see st is equal to st plus R1 of I. What is there in R1 of I? The value of I, keep in mind the value of I is 2, so this is 0, 1, 2. It means D is concatenated with the string. Now the next line, if you see the next line, the value of n, we are subtracting the value of n. So the value of n is 504. From 504 we have subtracted R of I. It means the value of R of I is 500. It means 504 minus 500 will give you 4. We are coming out of the loop. We are not further traversing in the list. We are coming out of it, and then we are going for a recursive call. In the recursive call, what we are doing, that we are passing n as function argument. So the value of n is this one, and the second one is st. So st, the value of st is D. This is copied over here. Now again it tests the condition here that whether the value of n, so keep in mind the value of n is 4 now. So 4 is greater than 0. It is entering this loop for I in range 0 to length of R. So again it starts traversing in the array, and it checks whether n is greater than or equal to n means 4 is greater than R of ith position value or not. So it checks each and every compartment again, and a match is actually found in this particular position. That is wherever 4 is written, the match is found. That is in the 11th position. So when it is satisfied, the condition is, when this condition is satisfied though, so it gets into it. So the last value of st was D, and with D actually R1 of I, so the value of I is 11, you know. So R1 of I is having IV in it, so IV is concatenated here. So what is there in st now? In st now we have got D, previously stored D, and with that I and V is concatenated, so it is IV. and n is equal to n minus r of I. So what is n? N is 4 and 4 minus 4 is 0. So we are breaking the loop and we are coming out of it, and now it is again going for the recursive call and checking here whether the value of n is greater than 0 or not. So this time it is not. So the return statement, whatever is given here, is executed and it is returning the value. So this is how the entire program is running. If you want to take any other value, say 198 is taken, so we will check out whether it is running or not. So this is the output that is generated. Now what we'll do, we'll run a for loop here in this particular part, and we will put everything in the for loop. So we'll write for I in range, we can write here 1 to say 200. So we are generating a loop here and we will be producing all these values. So RR is the function call made here, so a bit of indentation is required, so I'm indenting the program a bit, and in this particular part we will be passing I as function argument. Now a bit of change we will make here, that is, instead of printing s directly, otherwise you will get confused. So I'm writing here I, and then within double quotation I'm just keeping one arrow so as to track that Roman equivalent of which number is generated. So I'm saving it and running the program again. See the output this time. Now you can see that 199, this is the value of 199.98. So in this way it has generated the output of all the values starting from 1 to 200. It means the last value generated here is 199, because in for loop it moves up to n minus 1. So hopefully you have understood this particular part. So this is the recursive version. As far as the base case and the recursive case is concerned, this is actually the recursive case. Recursive case is the area where the function call is made. So this is the area where function call is made. And this is the base case, that is terminating the function directly. When this condition becomes false, it returns, that is, it is terminating the function. So there is one base case and one recursive case in this function. Now we will write one more function, that is Hailstone number. So for this I am defining a function. Say the name of the function is hs, and I am taking one argument here, that is n is the argument. And now we will test few of the conditions here, that is whether the value of n is less than 2 or not. If it is less than 2, then in that case what we will do, we will directly print the value of n on screen. And if it is not, so I'm coming to the else part. If it is not, then what we will do, we will again print the value of n here. And after printing the value of n, we will test a condition here. The condition is whether n modulus 2 is equal to 0 or not. So I'll come to the explanation of the program. Let me first write the code here. So I'm calling the function here. hs is the name of the function, and this is the argument passed. And I'm taking one else part of this one, and in the else part again I'll be calling this particular function, that is 3 asterisk n plus 1. Now let us demarcate it a bit so that you can understand that from here where it starts. So this is actually the function. So concentrate in this particular function now. This is Hailstone. What is Hailstone now? Hailstone number means if you start with a particular number, say the value of n happens to be 1, then in that case just print 1 and stop there. Now if the value of n happens to be one even number, then divide it by 2. And if the value of n happens to be an odd number, multiply the number with 3 and add 1 in it, and continue this process. How long this process will be continued? The process will be continued unless and until the value of n is converted to 1, or it is reduced to 1. Now we will run the program and we will check out whether the codes written by us is correct or not. So I'm commenting this part of the program, and we will write a new main here. So you know that HS is not returning any value, it is a void type function. So I am passing one argument first. So the argument is 9, so the value 9 is copied here. It is checking 9 is less than 2. This is false, so it is coming to the else part. It is printing the first value, then testing here, that is n modulus 2 is 0 or not. It is also false, so it is coming to the else part. Then what is happening? 3 into 9, 9 3 is 27 plus 1 28, so 28 is generated, and again it is there in n. So the value of n becomes 28 next. When it becomes 28, then it again tests the condition whether n is less than 2 or not. It is not, so it comes to the else part and it is printing 28 on screen. And now n modulus 2, it is 28 modulus 2 is a even number, and therefore 28 divided by 2, so you are getting 14. So 14 you are getting, so again it moves for the next iteration. So the value of n is now 14. 14 is less than 2 or not, so 14 is not less than 2, so comes to the else part and prints the value there. So 14 is printed here. Now again testing whether 14 modulus 2 is equal to 0 or not. So this is true, so therefore n equal to n by 2, it means it is converted to 7. In this way it is running. Now let us run the program first and check whether it is producing correct output or not. So you can see here 9, 28, 14, 7, 22, 11. In this way it is generating all the numbers, and ultimately it has reduced to 1. So one thing is there that there is no proof that whether all the numbers that we pass in Hail's sequence is reduced to 1 or not. There is no such proof, but in all the numbers, almost in all the numbers, it is found that it converges itself. It is reduced to 1, all the numbers. So let us test few other numbers. I am taking one number, that is 35, and let us generate the Hail's sequence. So this is for 35, and you can see the last number is always 1. Now let us take one even number. So I am starting with 28. So 28 is the number here. So first 28, then 14, 7, 22, 11, 34 in this way, and now you can see that it is reduced to 1 again. So whether you are taking odd number or even number hardly matters. So it generates number in this way. Now if I write 1, then like this, it means the program is perfectly okay. As far as the base case and the recursive case is concerned, this particular function is having one base case in it. So this is the base case. Base case means the case where we are not calling the function, no recursive call is made, and the recursive case is the point where we are calling the function again and again. So as far as this particular function is concerned, there are two different recursive cases here. You can see that we are calling the function in two different areas. So it may happen in a program that a particular program may have two recursive cases and one base case, or it may have two base cases and one recursive case, or it may have two base cases and two recursive cases. So it depends that what type of code you have written, how you have written that program, it depends all on that. So I think you can match it with one of the program that we have written earlier, that is binary search. In case of binary search also we have seen that two recursive cases and two base cases were there. So it may happen in a program. So I hope that you have understood this particular part, you have learned this part nicely. So this is actually the recursive version of the program. If you want to make a note of this one, so you can make a note, and this is again the recursive version of Hailstone number. I hope that you have learned from here, and you have understood each and everything. If you are having any doubt or problem, then you can write me directly in the comment box or in the WhatsApp message group. Thanks.